will indicate in the diagram. Huh? Having mass and initial temperature θ1. Okay, this is θ1. With unknown liquid filled in calorimeter, let mass of liquid and calorimeter are M2, M3. Okay, this is θ2. Okay, final temperature is θ. Okay, I think this is very important. The what we have M1, no? M1 is mass of this. M2 and M3. Let mass of liquid and calorimeter are. Okay, this is M2. Okay, now we'll get into, you know, heat exchange, heat loss by the sphere. The sphere is what put into this one. So are you seeing the second diagram, the third diagram, where the sphere is there in a in a calorimeter where they'll attain the equilibrium temperature. Sphere is immersed in, or sphere is put will write it. Sphere is put in calorimeter. No, I think heat exchange we know. So I think directly what is the, so what we are needed, specific heat of capacity of an unknown liquid using. So the specific heat of liquid is needed. That's what I'm writing. Okay, this formula, okay. Just see once. So this S2 is what needed. So to know that S2, what all we should know, M1, S1, θ1, theta. How to measure the temperature by using thermometer. I'll immerse a thermometer. The temperature is going to measure. and strict condition is putting steady state. What do you mean by that? The moment you drop the sphere into the calorimeter, you should measure, or after some time. In exams, they'll ask you, what is the steady state time? Is it millisecond, few seconds, or 5 minutes? In lab, usually what we do, I'll drop the sphere into the calorimeter. Will I wait for 10 seconds? Or it's like a 1 minute or 5 minutes. So what shall I do now? 5 minutes is what there'll be sufficient, or some days in some lab manuals, no, they're given 10 minutes also. It is good. But anyway, calorimeter is what, like, we will be insulated, no problem. 5 minutes is what's advisable. So you have to wait for 5 minutes. 5 minutes means it'll become steady. There'll be enough exchange of heat will occur between the sphere and the liquid. So there'll be exchange of heat will occur and thermal equilibrium will be attained. Not immediately. So in exam, they'll test experiment lab questions, practical questions like the sphere immediately after dropping, the temperature of mixture should be measured. No, after some time. After some time, it should be measured. That's meaning of steady state. So like this, I can measure the specific heat of the liquid. You see, there are so many things are there. I'm not going to pour this. You have the to give initial temperature θ1 to the sphere, we keep in steam chamber. This everything is a steam chamber, anchored by thread. Within some time, say 15 minutes, it achieves a constant temperature θ1. The sphere, it's a steam chamber. Then what I'm going to do? So I'm going to remove this disc. So this particular and the thread, what happened, will be removed, and the sphere will fall. Because you can't hold that odd sphere and something, no? So there's a mechanism. Wooden removable disc is removed and the thread is cut. The thread is cut, wooden, the sphere drops in water current system and mixing starts. Why can't we hold the sphere and bring it here? Why we should do here? So let this be in some other room, and let this be in one room number one, room number two. From room number one, what happen? I'll bring this sphere. By the time you bring it from here to here, convection will occur, and the temperature theta one what you measured will be less than that. So therefore, immediately it should be drop that one. The moment you open the disk cut, it will get dropped. And there should be what should be the distance? This one 100 meters, few meters, and it should not be very high, 20-30 meters, because as it falls, convection will occur. So usually in the lab, no, this will be around some 3 or 4 centimeter, not that much of big. Again, the liquid should not be splashed, no, so it will be just gently, it will be dropped. Though you remove the disc, no, so the thread is lowered, then I'm going to cut it and it will enter. Initially, what will happen? Any convection will occur between the sphere and the liquid in the calorimeter. Yes, no, there'll be convection. There'll be convection. There'll be convection will occur. Then due to convection, heat will flow inside the calorimeter. Then equilibrium is achieved. Let's not bother that convection ideas here. We are bothered about temperature at equilibrium. That is enough. So they may test you here. There'll be exchange of heat between the sphere and the liquid, and how the heat will flow inside the water through convection, because this will be hot, this will be cold. No, there'll be movement of material. So will there be any movement of water molecules after adding the sphere? Yes, it is due to convection. Heat from the sphere to the water will be conduction, but between the water layers, it will be convection. Okay, that's the idea. This will be conduction. Definitely the water will come in contact, but actually what's happening, the given layer of water will not be contact. The one which is in contact, what happen? It will rise up, no? Then the next layer will come. Like that, there'll be convection current will be there here. So a given layer of water will not be in contact with the sphere, because the layers, convection current will be like this. That is the idea. So they may introduce some convection also. Be careful. What is a possible error in measurement of specific heat? Some to specific heat where like that of the liquid, no, that of the ball also we can measure. This is for liquid we have measured. No, can I measure the specific heat of any metal? So I know now the liquid. I'll come for the metal, the body of the liquid as well salt. So this experiment, what happened, is used to measure the, I'll write it here. Regnolds apparatus. Regnolds apparatus is used to measure the specific heat Okay, fine. Regnolds apparatus is used to measure the specific heat of liquids and solids. No. For solids, no. This one is unknown. No, he's asking what are the possible errors. I think you know error analysis. Carry on with that. Usually what happens, the masses will be absolute, no? There won't be error. There won't be, you can say, error in the measurement of mass. So only the measurement of temperature. Why the error will be there. Why I'm focusing, why I'm not taking this parameter? Because I know the specific heat of the liquid as well as the calorimeter. There won't be any possible error in that one. So now that of the solid, what will happen? I'm checking this one. Now you see this. There'll be error in measurement of temperature. So many errors are possible, no? Is it a random error or systematic error? Anybody wants to share this? Is it a random error or systematic error? It's a random error. See, any instrument must have a random error. So there's a random error. So that particular thing will be reflected like this. It's a purely errors one. So that will help us. This errors will help us a lot of assuming some conditions here. Steady state temperature it is called as. The error in measurement of specific heat of solid will be least when steady state temperature is theta 1 plus theta 2 by 2. And there's one condition he has put it. Please do note down. This is something very important, not there in books. But in lab, what happened, we do follow this condition to minimize the error in measurement of specific heat of solid.